Hey everyone, in this video we are going to go over our brain model. All of the terms that we're going over today could be in your practical, so you are expected to be familiar with them. The anatomy that we're going to cover is both external and internal for the brain. As you can see, we can dissect our model apart. I want to note to you that when it does come time for your practical, if you need to dissect the brain apart to get to a feature, that's perfectly fine. However, you need to be familiar with how to put it back together in case you end up feeling a little disoriented and maybe need to start from scratch. So if you happen to, take all the pieces apart, it is up to you to be able to reset and put the pieces back together. So I'd like for you to practice with that so you know that you can properly take apart and put back together the model. The other thing is there's a couple of inconsistencies on our models. They're not completely accurate, but I think for our purposes, we're able to make it work pretty well. So let's go over the first set of terms related to the cerebrum. Right, so the cerebrum of the brain is this superior portion here where we have these lobes. And as you can see pretty clearly, there's a great divide between the two halves of our brain. Our cerebrum has a right hemisphere and a left hemisphere that is separated by the longitudinal fissure. So that's what that division is, that longitudinal fissure. The other thing I want to note is you'll probably recognize this noodly looking pattern as well as the grooves in between them that are kind of associated with the appearance of the brain. Each ridge or noodle, not that I have a better term for that, is a gyrus. If we're talking about one, gyri if it is multiple. And the folds or grooves in between are called sulci, or if we're just talking about one, it's a sulcus. That's going to be important when we are talking about different grooves that are particularly named, as well as if there's a gyrus that has a particular name, you know that you're either looking for the groove or you're looking for the ridge. Okay? Let's go ahead and go over the lobes. There are 5 lobes of the brain, 4 that are going to be on the surface. So we'll go over our surface lobes and then I'll show you where that 5th one is hiding. Right here to the anterior, we have our frontal lobe. Towards the sides, here we have our parietal lobes. At the back, we have our occipital lobe. To the side, we have our temporal lobe. Now, these are the lobes that are on the surface, and they are going to be separated by different features. For our purposes, I've gone through and put a dotted line at the division between our frontal and parietal lobes. That is our central sulcus. Okay. And the ridge anterior to that line is what we refer to as our precentral gyrus. You can see it travels from the longitudinal fissure down to this section, which we're going to name that in just a second. And then there is a gyrus posterior to this central sulcus, and that's our postcentral gyrus. Right. So anatomically, the precentral gyrus is located on the frontal lobe. The postcentral gyrus is a part of our parietal lobe. If we are looking towards the posterior, our parietal lobe is going to be separated from our occipital lobe through the parieto-occipital sulcus. Here's one that I'm not super thrilled with how the outline turned out. I was trying to follow the ridges that the model provides, but I think for our purposes, it will be okay. If we turn to the side, where we have our temporal lobe, we're going to have separation from our frontal and parietal to the temporal lobe through the lateral sulcus. So that's what this division is here. Now, I mentioned we'd be able to see the insular lobe if we did a little bit of dissecting. So I'm going to show you here. I'm just going to pull off the frontal and parietal here a little bit. And you can see inside we have this little guy in there, right here. This section of gyri and sulci, that's going to make up our insular lobe, or you can also just refer to it as the insula, your choice of term, but either is fine. All right. Next, now that we've gone over the surface, we are going to dive into the mid-sagittal view. I'm going to swap out my terms and I'll be back in just a second. All right, so we've got our next set of terms. We are going to dissect into the brain. Before I split it apart, I do want to note 3 structures that we're going to see on the inferior portion of the brain. And these are some of the cranial nerves. Now, there are 12 cranial nerves. We are going to just cover these 2. I think they are best visualized on this model. Some of the others are a little more difficult. And I think that's just a little bit beyond our scope, but just be aware that they are in existence. So let's start with our olfactory nerve. We have these 2 parallel lines, these white lines here. These are our olfactory nerves. And so this is going to be our nerve input responsible for your sense of smell. Just posterior to that, you have these 2 structures that have been highlighted white. They have been cut. These are your optic nerves. You'll see that we have 2 of them, of course, going to left and right eyes. However, if you think about the left and right eye seeing their own view, we need to be able to bring the vision of your right eye and the vision of your left eye together to make one cohesive line of sight. And to do that, we have a structure called the optic chiasma here. And this is this little X portion where the left and right eye are going to trade information, so that way when it gets to our occipital lobe, that information can kind of be puzzled together from our optic lobe, so we can make sense of just one surrounding versus having, double vision, or yeah, I'll leave it at that. For the next few, we're going to go ahead and open the brain. I'm just going to use 1/2 for now. There we go. And one of the most obvious features to me is the corpus callosum. That's this feature here. Our corpus callosum is going to connect our left and right hemispheres of our brain. If an individual has a contact injury like concussion, this can experience some damage, or there are cases where individuals have had this surgically severed if they are experiencing epilepsy, which is a very unique procedure we'll talk about later on in the unit. But the reason that your left and right are able to correspond with one another is because of this corpus callosum. Just below it, this section here, we have the septum pellucidum. This is a thin membrane that resides between our hemispheres. And then this white structure is our fornix. This has to do with transferring information to the memory or the hippocampus. That's going more into the limbic system, and we are covering more autonomic features. But yep, that is the fornix. For the next few features, I kind of picture like a little bird. So if this is his beak and this is his eyeball and his pupil, I think that kind of helps you orient where you are. The head of the bird is our diencephalon. And it consists of, this rounded structure, this large round structure, the thalamus. What I consider to be the pupil would be the intermediate mass. This is going to connect with the thalamus of the other side. And then where its beak is, here would be our hypothalamus. So that makes up our diencephalon. If we continue in this area, just behind the thalamus is this red, it's a little bit circular structure here. That's going to be our pineal gland. This is going to be responsible for the release of melatonin, right there. And then we get into the brainstem. And so the brainstem is our connection between brain and spinal cord. It's going to consist of our midbrain, which is this superior portion here, where I'm kind of highlighting. Our pons, which is this rounded portion. And our medulla oblongata, which is this area where it tapers off, it becomes a little more narrow. And then finally, it leads into the spinal cord. Now, all of these structures here in the center can be visible on the left and right on our model. However, there's a couple of structures I'm going to pause so that you can see that only the right side of our models have. So we'll go over those with the other half. So on our model, just the model, the right side has specific features highlighted that the left side does not. So that's why I've switched sides here. And we're going to talk about the fluid that is circulating throughout your brain, its role here and where it is going to be stored and manufactured. You have a fluid called cerebrospinal fluid, or CSF. This spinal fluid is going to be important for quite a few reasons. It serves kind of like shock absorption and has kind of like a protection for your brain. That fluid can help remove waste. It could help nourish different tissues of the brain, distribute hormones, carries neurotransmitters, various things going on there. And you actually have a couple different places in your brain where that fluid is, I don't necessarily want to say stored, but circulated through. The first that we're going to talk about is the lateral ventricle. The lateral ventricle, you actually have two of. You have a left and right. And for us to see that, I'm just going to pull off the temporal and occipital here, and I'm going to pull out the diencephalon brainstem. And here you can see we have this cavity here. And we're going to have cerebrospinal fluid circulating through this area. As you can see, it fits nice in there, but there's still a gap. That's going to allow that fluid to flow. This is our lateral ventricle. If we were to take the other half of our model, you can still see the ventricle there. So that cavity is there. But the reason that I have pulled just the right side here is because of this purple structure. this here is our choroid plexus of the lateral ventricle. And the choroid plexus is the structure responsible for producing that CSF. Okay? From there, our lateral ventricles, both left and right, are going to connect to our third ventricle. That third ventricle is going to be the space that bathes the diencephalon tissues here. They connect through a structure called the interventricular foramen. The lateral and third connect. But that is not a structure that we have on our model, so you are not required to know that. I just want to let you know that they do have a connection. And then here in this region where fluid would be flowing through, we have another choroid plexus, which is the choroid plexus of the third ventricle. So this is going to be producing CSF as well. And then if we follow this little tube-like structure here, that's our cerebral aqueduct. It is going to lead us to our fourth ventricle. And this kind of has like a diamond triangular shape here. And that's our last ventricle for cerebrospinal fluid in our brain. Last thing we need to talk about is the cerebellum. So we have a pretty good view of it here. I'm just going to bring over some different terms. So our cerebellum on our model is green, and it is separated from the rest of the cerebrum through this division known as the transverse fissure. Okay? But if we look at the inside, what's pretty unique is these branch-like structures called arbor vitae. And that arbor vitae is going to be our white matter in our cerebellum. Our cerebellum plays a very important role in your posture, positioning, and balance. But as it plays an important role, it needs to be able to communicate with the rest of the brain. In order to do that, I'm just going to pull our cerebellum off here. We have this little structure here, which conveniently has a little magnet in it. That is our middle cerebellar peduncle. Okay, and if we turn it over to look from the pons, you can see the other half of that connection. This is going to be where our cerebellum and our pons link together to communicate. So that's the middle cerebellar peduncle. So in this video, we have covered everything that's going to be on your practical. Again, I advise that you have practice taking apart the brain and putting it back together so that you can be familiar with all of its external and internal features. Of course, if you have any questions, don't hesitate to ask.